let's start. Last lecture, we were talking about image filtering, and we covered several concepts which are important to understand this fundamental operation in computer vision. Today, we are going to continue that, and we'll talk about image derivatives. Now, derivative, this is again coming from your high school maths. So if you remember, like the definition, derivative just gives you rate of change. All right, and again, it can have various different meanings depending upon the context. A simple interpretation could be, if you have a function, then if you compute a derivative on that function, it might give you, like, at any point in that function, the slope of that function, right? And if you look at like your day-to-day life, if you're, let's say, driving a car, then again, if you try to compute the derivative with respect to distance, with respect to time, you will get speed. Again, if you try to compute derivative of speed with respect to time, you will get acceleration. So that's real world interpretation. The simple formula to compute a derivative is shown over here. So let's say you have a function f, and it's defined over a domain x, which is the values which this function will receive. So if you take a very small incremental step in this axis, in the x-axis, right, then you assume that step is very small, and then you observe how much the function response is changing. All right, so that's what is being shown on the numerator of this function. So fx will give you the value of this function at x, so x could be anything. And then you change this value of x with a very small amount, which is like, you can say the limit goes to 0. And again, you try to observe the response of this function. And then you take a difference between these two, which says that how much the function is changing over this very small interval. And then you try to normalize that using this interval. So this will gives you like how fast your function is changing, okay? And as I said earlier, this is also like, you can say, what's the slope of this function at this point? So this is represented as f, this single dash over here. And you also use like a subscript x to represent a single derivative, okay? Now let's quickly go through a few very simple examples. Like you might have a function, something like this, x squared or x times 4. You add these two values. And again, this is high school maths, just to recap, all of you should know this. And you can compute derivative of this function with respect to x, which is represented as dy over dx. And we have the formulas. Again, we are not going to go over those formulas. This will gives you like 2 times x and 4 times x cubed, okay? Similarly, you can compute like derivative of other functions. In this case, it's not just like function of x. You can have like a sine function on top of that, or you can have a cos function on top of that. And again, these are coming from like the formulas which you might have learned in high school. So a derivative of sine function gives you a cos function. And if you compute derivative of an exponential function, it gives back you exponential with the sign which you are using like in the exponent.